Alright, how's it going? This is Sam Welker with thinkparticle.com, and this is the TP Toolkit Visual Documentation Series. And in this video, we're going to be covering two different objects from the TP Toolkit plugin, which can be found at thinkparticle.com. So in this video, we're going to be talking about the dynamic collision emitter and the TP dynamic collision point emitter. So these are two different emitters that will emit particles based off of a collision point. Okay. So, or based off of a dynamic collision. So, the first one we're going to use is the TP dynamic collision emitter. Okay. So, when you have a collision, it will emit particles. Okay. So, every time the dynamic objects collide, it's going to emit some particles, and then those can either you can set it to either collide with your object or not. It could be set to just, I think you can have it set to, you can have it set to follow, inherit the velocity of the object, things like that. So the way this is done is you go ahead and go to the TP Toolkit plugin and drag in, select the box for the TP Toolkit collision emitter or the point emitter. So for this one, we're going to just do the collision emitter. And to set it up, we're going to just check that off. Okay, so we're going to skip the MoGraph section. If you want to learn how to do that, look at the TP MoGraph emitter video. And then we're going to go to the particle group. And you can find that with the thinking particle settings. Here, let's go ahead and go to the standard user interface. Okay, and that's under Simulate Thinking Particles settings. And to put that in there, we just need to drag in that thinking particle group into the particle group. And then the emitter is going to be our sphere. Okay. And then we need a collider A and a B. So we're going to set those up with a sphere and a plane in this case. You could do just about anything that dynamically collides as long as there's an object that can collide. An editable object. So now we're going to have the sphere, and we're going to turn the particle count from 150 to 15,000. And next we're going to make sure that it emits only for 0 frames on the collision emitter. What you can do is you can set that to something, say 90. So it'll emit for 90 frames every time it collides. You can set it to 2. It'll emit a few more particles than it normally would, just on a single collision. And it can emit only on collision, or it can emit just while it's touching the object. So if you actually watch this video at the very end, it stays on the ground, and then it will continue to collide. And then it can collide with the emitter, and you can actually disable that so the emission actually does not collide. So that would be cool for something like a pulsing radar effect, like an energy wave. And then you have your collision settings, and this has the front side of a collision, so you can collide with the front of the object, or you can collide with just the back of an object. So if you actually watch, then it'll collide down here, and it's colliding on the back side of the polygons, so the inside, or both sides. So you'll get a very interesting look there. Now, I personally don't think that always works very well, so I usually just leave it on front, but the options there. It's not the best option for dynamic simulations if you want to simulate something like that. I'd rather use flip fluids would be good, but the pop network in Houdini is a lot more powerful. Now, if you don't have Houdini, go ahead and check out something like X Particles or Navi Effects, I think, does water simulation, and that might help you do particle simulation with better collisions. Anyways, the offset now, you have the particle size of travel X, Y, and Z, the user-defined travel X, Y, and Z. So you can actually collide with the particle and its actual size. And then you can also collide with a user set value. So if I set that something really big like 150, then it will have a very big collision radius. So you can set it to, say, 25 and have 100% variation, and that will allow you to have more variation in the particles landing above it. So as you can see here, well, you can't see it very well, but the particles are more varied in their position. Okay, and then bounce, we can turn that up, and the particles are going to bounce off of this really big, except for they're not as much. So if we add a little bit of velocity inheritance, it's actually not going to stick as badly, though it's inheriting just a little weird. Maybe a little bit more velocity inheritance. No, I guess not. Anyways, so the bouncing causes the particles to bounce off of the object more. Then you have your variation on that. Surface, energy, friction, spin, chaos, velocity, inheritance. These are all dynamic, TP dynamic settings, which can be found under, let's see, the help menu. If you type, I think it's dynamic or P dynamics. Let's see, really quick. One moment. That is because the object is actually not called dynamics. It's called the P deflector. So if you look up the P deflector in thinking particles, you can actually find all of those settings in better detail. You have the surface, energy, friction, spin, chaos, and velocity inheritance. So that's where you can find more on those. Go ahead and just look that up under your help menu, under content, thinking particles, nodes, TP dynamic group, and P deflector. And then just look at the parameter page. So there you go. And if you want to pause the video, I'm sure you could just, I know it's inconvenient, but you could read it all right there. Next, the life is covered in all of the other emitter videos, so I'll just keep it very brief. And same with speed, and size is covered in the matter waves, or not matter waves, that's the emitter, the TP matter emitter videos, so I'll cover those as well, but just briefly. So the lifespan of a particle is set here, so it's how long the particle will live for after it's emitted. And then you have a variation, so if you set it to 100%, it will go up to 15 frames of life, in this case, up to whatever value you set. So, and then it'll go from 0 to that number. If you set it to 50%, it will cut that number in half, and then it will go from that number in half to that number. So 30 would go down to 15, so it'd go from 15 to 30 frames of life per particle, depending. It will randomly choose them. The same thing applies to the speed. So when you have your speed, you have an emission speed, and if you vary it, it will go, basically, you take that number, and then you take the percentage of that number that you select, and then you subtract that. So 150 units, 100% of that is 150, so it'll go down to 0. If you set it down to 20, then that will go to, what is 20% of 150? I think it's 30. So it would go to, it would go down 30. So it'd go between 120 and 150, I believe. So for the speed. So that is how variation works. Then you have your size of your particles, and this is going to be easiest to explain if we had a cloner and a cube to the cloner. And then we just add the object mode and add our particles. Okay, and then we're going to set the particle scale to 100%. Okay, so now our dynamic collision emitter is emitting cubes now. And those, if we set the variation of size to 100%, are going to vary in size between 0 and 10 on that unit. So that's a multiplier that basically takes these cubes and multiplies it. I think if you set them to 100, they will be normal size. Yeah, okay. So it's not a percentage, but it's kind of like a percentage. So if you set that to, say, 5, it'll be 5% of the normal size of a cube, plus the variation, or I guess minus the variation. So there you go on that. And then also distance. So this is the distance from the actual polygons that this is emitted. So it's, say, if you set it to 2, it'll be 2 units from the polygon. If you set it to 2 or 25, when it's emitted, it'll be further from the polygon. So as you can tell, when they hit, it's much further. It's easier if we make that number bigger, though. So as you can tell, when you're emitting, it's got that distance. And then if we add variation, that again adds that variation. So it's kind of cool. So we'll set those both to 0, and then the direction variation is best explained if we just turn it all the way up to 180. So now you can see that they all move, every particle just moves in a different direction. Normally they move away from the polygon along the normals of the polygon. So if you have a polygon on your sphere and we'll make it, let's see, we have normal selected and cube. So those little lines, each polygon has one. It's called a normal. It's the direction the polygon is facing. The particle emitted from that polygon will go along that normal, unless you change the direction variation, and that will cause the, I've crashed it. I've crashed it. I guess that's a weird little bug. Anyways, that will allow the, I'm going to fix this. One moment. Alright, so now that we've recovered from that crash, we're going to finish just by giving that final example, and then we'll talk a little bit about the difference in the point emitter. Okay, so the point emitter is, I think, the same, except for the direction. Yeah, the direction variation is the only difference. Okay, and there are not collision settings with the emitter because it doesn't collide from an emitter. It just has a point. So what we're going to do is we're going to go to the TP Toolkit and add the TP Dynamic Collision Point Emitter, and we'll just put a particle down for this one, and we'll just use 1 or 2, and we'll add it to the TP Toolkit group. I'm going to go back to the standard menu and hit play. Okay, oops, we need to turn this guy off. And you'll notice that that particle needs to have these guys. Okay, that particle will emit at the point of collision after we have these 2 particles set. Not doing everything right here. Hold on. Okay. It will emit at the point of collision once you have these 2 objects set. It should. Alright, well that was weird. I don't know what happened, but it works now. So I've changed just the number of particles up to 1500. And also, when you do this, make sure you uncheck Collide with Emitter in the TP Collision Emitter object. If you don't, and you're using some particles at some point, they're just going to get, I guess, smashed by the collision. So that might be weird. And if you see that going on, just make sure Collide with Emitter's unchecked. Okay. Let's see. Yeah, so the particles emit from right there. If we give them a little more speed, it looks more like an explosion, because it's an awesome explosion, because that plane is really happy that the ball hit it in the face. Okay, there you go. So that is how you use that and the direction variation in the FOV values. This is the X FOV, and if we set that to 0, you'll see right here that the particles emit only on the Y and Z axis. Okay, they have 0 direction variation in the X axis, and that is for the collision point. And then we can do the same thing with the X axis, and that will not emit along the Y axis. And in this case, it's actually flipped. It's not moving along the I guess it is moving along this. It's moving along the y-axis and the z-axis of this plane. So that is how that works. If you have any questions, go ahead and leave them in the comments below. And thank you very much for watching this and for checking out the TP Toolkit. We're really excited for all the great videos that we have in store for you and the updates we plan on bringing to you. And go ahead and check out thinkparticle.com to get your copy now if you haven't gotten one yet. The 1.3 release is either coming shortly or already out, and we're excited to keep bringing you more ideas and more tools, so go ahead and give us some good feedback if you pick up your copy. And you can find the rest of this series on thinkparticle.com. I'm Sam Welker, and I'll see you guys later.